In this video, we are going to solve equations in the complex numbers. The first equation is this: z to the 2 plus 2z plus 4 equals 0. As you can see, we have a quadratic equation. For solving this quadratic equation, if you try to factor this quadratic expression, you are not going to be successful. If you try to find two numbers that their product is 4, their sum is 2, you cannot find any two real numbers. So, we use quadratic formula for finding z. Let me remind you the quadratic formula for solving quadratic equations. If we want to find x from this equation, ax to the 2 plus bx plus c equals 0, x equals negative b plus minus radical b to the 2 minus 4ac over 2a. Based on this formula, here z equals to negative b would be negative 2 plus minus square root of b to the 2, 2 to the 2 would be 4, minus 4 times a is the coefficient of z to the 2, which is 1. So minus 4 times 1 is minus 4, times c is 4, so minus 16. 4 times 4 is 16. So we have minus 16 all over 2a, 2 times 1 is 2. So z equals negative 2 plus minus radical 4 minus 16 is negative 12 all over 2. Now please pay attention. Radical negative 12 is basically the same as radical 12 times radical negative 1. And 12 is 3 times 4. So we can write 12 as 4 times 3 times radical negative 1. Radical 4 is 2. So we can write this radical in the form of 2 radical 3. And radical negative 1, when we are in the complex numbers, we have named radical negative 1 a square root of negative 1, I. So let's continue our solution for z. Negative 2 plus minus 2 radical 3i over 2. If you pay attention, the terms in numerator both have 2. So we can divide the terms in numerator by 2, and then we have z equals to negative 2 over 2 is negative 1. 2 radical 3i divided by 2 would be radical 3i. The 2 from numerator with the 2 from denominator cancels. So these two numbers, these two complex numbers, are the solutions of this quadratic equation. Let's move to the next equation that here we have. iz equals 4 minus iz. You know that when in an equation we have I, in the complex number I means the square root of negative 1. For finding z, simply we can move the unknowns to the one side and other things which are numbers to the other side. So here is a good idea to get rid of negative iz in the right side. So we move negative iz to the left, or in another word, we add iz to the both sides of this equation. So by adding iz to the left and to the right, we have 2iz equals 4. And so z equals 4 divided by 2i. Maybe here you are thinking, so this is our solution. If we simplify numerator and denominator by 2, z equals 2 over I. But attention, this is the answer of this equation, but this is not the proper form for the answer. Remember, whenever we solve an equation in the complex numbers, the z, the answer of the equation, should be in the form of a plus bi, which a shows the real part of the answer and b is the imaginary part of the answer. Always our answer should be in this form. But is our answer here in the form of a plus bi? The real part of this answer is 0 because we don't have any real part. But the I should not be in the denominator. So we have to fix this problem here. So this is not our final answer for this equation. Z is 2 over I, yes. But we have to continue and simplify this answer and write it in the form of a plus bi. To do so, we have to divide 2 by I, which is in the denominator. And if you remember, from dividing complex numbers, to divide two complex numbers, we multiply numerator and denominator by the conjugate of the denominator. What is the conjugate of I? Conjugate of I is negative I. So we multiply numerator and the denominator by negative I. Let me remind you, when we want to divide a complex number, let's say a plus bi, by c plus di, we multiply numerator and denominator by the conjugate of the denominator. And conjugate of c plus di is c minus di. So here, in the denominator, we have only I, basically, which is like 0 plus I. And the conjugate of 0 plus I is 0 minus I. That's the reason here we multiply numerator and denominator by negative I. Now, if we multiply numerator by numerator, 2 times negative I is negative 2I. And I times negative I times negative I is basically like negative I to the 2. And we know that I squared is negative 1. So this equals to negative of negative 1, which is equals 1. So the denominator is 1 and the answer is negative 2I. Now if you pay attention, this final answer here is in the form of a plus bi, which here a is 0 and b is the coefficient of I, which is negative 2. Now this is the answer of this equation, z equals negative 2I. Attention, this answer is the same answer as this. These two are the same, but this is the answer that we expect to write when we work in the complex numbers. It should be in the form of a plus bi. Now look at this equation. Z over 1 minus z equals 2 plus I. Here, in the left side, we have a rational expression. Z is in the top, z is in the bottom. So, you can move 2 plus I to the left and do common denominator. But the better idea is to get rid of the denominator, like real numbers. To how we can get rid of 1 minus z in the left? We multiply left side and right side of this equation by 1 minus z. So the idea is we multiply left side and the right side by 1 minus z. Or in another word, if you suppose a 1 here, you can do a cross multiplication. It's the same thing. The result is the same. So we multiply left side of this equation and right side of this equation by 1 minus z. When we multiply left side of this equation by 1 minus z, what happens? 1 minus z with 1 minus z in the denominator cancels and only we have z in the left. What about the right side? Then we have 1 minus z times 2 plus I, or 2 plus I times 1 minus z. The order really doesn't matter. Let's multiply the brackets that we have in the right. Then we have z equals 1 times 2 is 2, 1 times I is I, minus z times 2 is minus 2z, and minus z times I is minus iz, or you can say zi. It's up to you. Iz. Now we notice that we have z in the right side of the equation, we have z in the left side of the equation, so I decide to move the z's, all the unknowns, to one side of the equation to factor z, and then we can find z. So here we move this term and this term to the left. Or in another word, we add 2z and we add iz to the both sides of this equation. If we do so, z plus 2z would be 3z, and we move iz to the left. So in total, what we have in the left, we have 3z plus iz equals 2 plus I. Now for finding z, we factor z and then we have 3 plus I equals 2 plus I. From here, z equals 2 plus I over 3 plus I. Again, here you should not leave z in this form. Yes, z equals this, and this is the value of z. But because in the numerator we have I, and in the denominator we have I in the denominator, we have to rationalize this. By rationalizing, we mean we want to divide numerator by denominator, and to do so we multiply numerator and denominator by the conjugate of the denominator. Similar to the previous example. When you want to divide two complex numbers, multiply numerator and denominator by the conjugate of denominator. So, to simplify this answer, we multiply numerator and denominator by 3 minus I. For numerator, we have 2 times 3 is 6, 2 times negative I, negative 2i, 3 times I, 3i, and minus I to the 2. But for denominator, please pay attention. When you want to multiply a number by its conjugate, really you don't need to distribute these two brackets like numerator. You can use this shortcut. 3 times 3 is 9. This multiplies by this, and don't forget plus times minus is minus, minus I to the 2. And this equals 9 minus negative 1, which is 10. But this is not actual shortcut. The shortcut is this. If you want to get this number, this is the shortcut that you can use always. When you multiply a number by its conjugate, you don't need to do even this. Please pay attention how I can get this answer right away. Always the answer is the real part to the 2. What is 3 to the 2? 9. Then plus always. What is coefficient of I here? It's 1. Plus 1 to the 2. So real part to the 2 plus imaginary part to the 2. And if you pay attention, this is exactly 10. So here I multiplied the two brackets by each other and I got 10. But the shortcut is this. When you multiply a number by its conjugate, don't multiply them by each other. Always the answer is real part to the 2 plus imaginary part to the 2. Something similar to the Pythagorean theorem. b to the 2 plus c to the 2. Something like that. So, anyway, when we multiply the denominator by each other, the denominator is 10. So we have 10 here. What we have in numerator? If you pay attention, negative I to the 2 at the end here. I to the 2 is negative 1. Negative I to the 2 is plus 1 or positive 1. 1 plus 6 is 7. So this equals to 7. Negative 2i plus 3i is just 2i divided by 10. So finally z is 7 over 10 plus I over 10, which you can write it as 1 over 10i. This is the proper form for our answer of this equation. Now look at this cubic equation. This is like a cubic polynomial in terms of z. Immediately when we look at this equation, we notice that z is common between the two terms. So what we have to do? When you have a common term, immediately you can factor that common term. So z times z to the 2 plus 16 equals 0. From this, we can conclude that either z is 0 or z to the 2 plus 16 is 0. So one solution for the equation is z equals 0. So this is one solution of this equation. But the other solutions we can find from setting this equal to 0. For solving this equation, you can use quadratic formula. But the easier way is to move 16 to the other side. Take a square root from both sides. Z equals plus minus a square root of negative 16. But attention, negative 16 is like 16 times negative 1. A square root of 16 is 4. So this equals to z is plus minus 4. And a square root, so we can write this as plus minus a square root of 16 times a square root of negative 1. This is 4 and this is I. So z equals plus minus 4i. Attention, the given equation is an equation of degree 3. We have z to the power of 3. And exactly we have 3 solutions. 0, 4i, and negative 4i. When we are working in the complex numbers or complex variables equations, if an equation is of degree 2, we have 2 solutions. If equation is of degree 3, this equation has 3 solutions. If the equation is of degree 10, it has 10 different solutions. Maybe some of them are repeated, but we have 10 solutions at the end, if it is of degree 10. Now look at this quadratic equation. Z to the 2 plus 2iz plus 2 equals 0. The coefficient of z to the 2 is 1, the coefficient of z is 2i, and the constant term of this quadratic expression is 2. For finding z, we use quadratic formula. Let me write the quadratic formula here. Z equals negative b plus minus radical b to the 2 minus 4ac all over 2. So z equals negative 2i plus minus radical b to the 2. b is 2i. What is 2i to the power of 2? 2i to the 2 is basically 4i to the 2. And we know that I to the 2 is negative 1, so this equals negative 4. 4i to the 2 is negative 4. So b to the 2 is negative 4. Minus 4 times a is 1. A is the coefficient of z to the 2 here, which is 1. So a is 1. Minus 4 times 1 is minus 4 times 2 is minus 8. So minus 4ac is minus 8 all over 2 times a, which is 2. The only thing that here we have to do is to simplify this answer and write it in the proper form. We have negative 2i plus minus radical negative 12. But attention, radical negative 12 is basically radical 12 times radical negative 1, and this is 2 radical 3, and this is I. So we have plus minus 2 radical 3 I over 2. Both of the terms in the numerator have 2, and so we can divide each of them by 2, and the 2 from numerator with the 2 from denominator cancels. So z equals to negative 2i over 2 is negative I, 2 radical I divided by 2 is radical 3i. Don't forget we have plus minus radical 3i. And this is the solution of this equation. But pay attention, please. This is important that you notice to this. Z is negative I plus minus radical 3i. Don't make this mistake to think that this is the real part of the solution and this is the imaginary part. Attention, both of these have I in common. So basically, it's not a bad idea to write this answer in this form. Factor I from these two terms, and then you can write this answer in this form. Z equals negative 1 plus minus radical 3i. Now let me ask you a question. We know that always we have to write our answer z in the form of a plus bi, which a is the real part and b is the imaginary part. In this answer here, if I ask you, what is the real part of z? What is your answer? And what is the imaginary part of z? The real part of this answer, the real of z, is 0. Attention, we don't have any number without I here. Basically, we have 0 plus this. So what is this then? That is the imaginary part of z. Imaginary part of z is negative 1 plus minus radical 3. Let's go to the next question. Z to the 2 plus 2i minus 3z plus 5 minus equals z. For finding z, again we use the quadratic formula. So z equals negative b, which would be negative 2i plus 3, plus minus radical b squared. b is 2i minus 3, which you have to raise it to the 2, minus 4 times a, which is 1, times c, which is 5 minus I, all over 2. So we have to simplify the expression inside the radical. Pay attention that 2i minus 3 to the 2 is basically like 2i minus 3 times by 2i minus 3. Or if you know this identity a plus b to the 2, you can do it faster with this method. A plus b to the 2 is a2, b2, 2ab. But if you don't know this identity, simply you can multiply 2i minus 3 by itself. If you multiply 2i minus 3 by itself, it equals to what? Let's see. 2i times 2i is 4i to the 2. 2i times negative 3 is negative 6i. We have another negative 6i here. And finally, if we multiply this by this, it's 9. Attention, this is negative 4. Negative 4 plus 9 is 5. And this is minus 12i. So finally, for 2i minus 3 to the 2, we have 5 minus 12i. So let me write this here, 5 minus 12i. So z equals to negative 2i plus 3 plus minus radical 5 minus 12i. What about the other part? Minus 4 times 5 is minus 20. Minus 4 times minus I would be plus 4i. And in the denominator we have 2. So this equals to negative 2i plus 3 plus minus radical 5 minus 15. 5 minus 20 is minus 15. Minus 15. And negative 12i plus 4i is minus 8i. All over 2. Here is the tricky part of this question. How we can find a square root of negative 15 minus 8i? Here you need to use a trick. We know that if we want to take a square root of a number, if that number is in the form of a to the 2, then we can take a square root of that number. But unfortunately, negative 15 minus 8i is not in the form of a bracket or an expression to the power of 2. So I am thinking to an idea. If we can write, please pay attention, if we can write negative 15 minus 8i in the form of something to the power of 2, then we can simplify this radical. But what should be in the bracket? Of course, in the bracket we have to have a complex number. Because here we have a complex number, so a complex number raises to a power of 2 equals to this expression. So we suppose that complex number to be a plus bi. Now, we want to find the value of a and b to make a plus bi to the 2 equals to negative 15 minus 8i. If we raise the bracket to the 2, it equals to what? If we raise the bracket to the power of 2, it equals to a2. If we multiply a plus bi times by a plus bi, it equals to a2. Then we have abi and another abi, 2abi, and bi times bi is b2i2, which equals minus b2. because I to the 2 is negative 1. So if we raise this bracket to the power of 2, we have a squared minus b squared plus 2abi. And in the left we have minus 15 minus 8i. Now the real part should be equal to the real part, and imaginary part should be equal to the imaginary part. So basically a2 minus b2 should be equal to negative 15, and 2ab should be equal to negative 8, which means that ab equals negative 4. Guess two numbers that their product is negative 4. If you think to those numbers, they can be either 2 and negative 2 and 1 and negative 4. Between these two pairs, which one is the answer? The one that a to the 2 minus b to the 2 equals negative 15. But 2 to the 2 minus this to the 2 is not equal to negative 15. But 1 to the 2 minus negative 4 to the 2, 1 to the 2 minus negative 4 to the 2 is exactly negative 15. So we know that a is 1, b is negative 4. It can be the other case, which a is negative 1, b is 4, but it doesn't matter which one to choose. So here we choose a as 1, b as negative 4. If you choose the other one, which is a is negative 1, b is 4, you will see that the answer is the same at the end. So from here, now we know that negative 1 minus 4i to the 2 is equal to this. So we replace this expression here with 1 minus 4i to the power of 2. 1 minus 4i to the 2. Power 2 and radical cancels, so we have negative 2i plus 3 plus minus 1 minus 4i. Divide by 2. If we consider the plus, we get one answer, and if we consider minus, we get another answer for z. If we consider the plus, we have negative 2i plus 3 plus 1, which is 4. So we have 4. Negative 2i plus negative 4i is negative 6i. Divide by 2, it would be 2 minus 3i. If we consider the minus, negative 2i plus 3 minus 1, 3 minus 1 would be 2. Negative 2i minus 4i would be plus 4i minus 2i plus 4i is plus 2i. Divide by 2. So the other answer is 1 plus I. So these are the two answers of this equation here. This was a little tricky question, really. Now look at this equation. Z to the 3 plus 8 equals 0. For solving this equation of degree 3, which has 3 solutions, if you think this way, we can move a to the other side and write it as negative 8, and then z equals q root of negative 8, and the answer is negative 2. In this way, you are going to find one solution of this equation. But we are now in the complex numbers, and we expect to have 3 solutions. But here you got only one solution for this equation. So this is not the method that we need here. This method is for real numbers. Here you have to look for 3 solutions because the equation is of degree 3. But how we can find all solutions? Here you have to think to factor the left side. You have to think to factoring z to the 3 plus 8. First of all, note that we can write z to the 3 plus 8 as z to the 2, z to the 3 plus 2 to the 3. because 8 is 2 to the 3. Now let me remind you an important identity. A to the 3 plus b to the 3 can be written as a plus b times a2 minus ab plus b to the 3. This is an identity that you can memorize. If we use this identity, then we have a plus b. What is a plus b in this case? A is z, b is 2. So z plus 2 times by a2, which would be z2, minus ab, minus z times 2 or minus 2z, b2, 4, equal to 0. Now by setting this equal to 0, z is negative 2. And this is one solution that was obvious from the beginning. And for finding the other solutions, we have to set this equal to 0 and solve for z. And for solving z, finding z, we use quadratic formula. Based on the quadratic formula, z is 2 plus minus negative b is 2 plus minus radical b to the 2 is 4 minus 4ac would be minus 16 all over 2. Z equals 2 plus minus radical negative 12. In this video, we have seen radical negative 12 several times. Radical negative 12 is basically radical 12 times radical negative 1, and radical 12 is 2 radical 3. So this is plus minus 2 radical 3i divided by 2. So z equals to 1 plus minus radical 3i. Radical 3i. These are the solutions of this equation. Attention, we have one solution here and two solutions here. So the equation has 3 solutions, as we expected from the beginning. I hope by watching this video you have learned how to solve equations in the complex numbers. And now you know the difference between solving equations in the complex numbers versus the real numbers. If you like this video, please subscribe to my channel and see you in the next videos.